when you think of a mole, what do you think of? So focus. Something that lives on the ground.
Something's on your face.
Something's on your face. Okay. Yes, these are things that you may have thought that are in your vocabulary of what a mole is. Okay? But according to a chemist, there is another kind of mole that we get to learn about. So in chemistry, we're dealing a lot with molecules, or we think about atoms. Now, remember when we did that lesson on talking about how small an atom was? Right?
Yeah.
It was really small. Super small. So, when I think of, say, sulfur, okay, so remember this is sulfur, just some sulfur. If, say, I was talking to my other chemistry buddy, and I was telling him how many atoms of sulfur I had, you know, I'd be saying, like, I have, like, 7 sectillion atoms of sulfur. People don't talk like that. That's silly, right? That's silly. You know, like, say you have, let me just do something. So say you have 168 eggs. Okay, say you go to your buddy and you want to sell him some eggs because you got chickens and you got eggs. And you say, I have 168 eggs. Do you want them? No. You say, I have 14 dozen eggs. Right? That's easier to think about. You know? Right? Yeah? Okay, so when we think of like, okay, 168, instead of talking about eggs and saying I have 168, you say I have 12 dozen. I mean 14 dozen. So that's how, you know, farmers or something, chicken herders, I'm just making stuff up, that's how they talk about eggs, is dozen. Yeah, just wing it. Okay, that's how they can talk about eggs. Scientists, chemists, need a similar way to talk about atoms, okay? Because there's just too many sometimes. So what they do is they use something called a mole. So this is 0.5 moles of sulfur. I measured it up. I didn't have to count the atoms though. And this is 1 mole of potassium sulfate, okay? So it's a lot easier for a chemist to say, I have this many moles of potassium sulfate than to say, I have 6.023 sectillion atoms of potassium sulfate. It's a lot more complicated, okay? So that's what a mole is for in chemistry. So why make a mole? So since atoms and many compounds are very tiny, scientists group them into an extremely large number called a mole. And then I already tucked your thing away, so I forgot. I was like, where is everybody? And I remembered you were
This.
okay. So this is a similar idea to a dozen. When we think about how we use the context of a dozen, that's kind of like why we use the context of a mole. So a mole is defined as the amount of a substance that contains as many elementary atoms or compounds as exactly 12 grams of carbon-12. And so it's like taking a reference point. We got to have something to compare it to, so we use carbon. Now, 1 mole of that amount of carbon contains 6.02 times 10 to the power of 23 particles of that substance. So that is this many particles. That's that many particles. 6.02 times 10 to the power of 23. So that's a lot of particles. That's how many particles of potassium sulfate are in here, guaranteed. That's crazy, right? But I don't go walking around saying 6.02 times 10 to the sextillion mole particles. I need something that's a lot easier, and so I say 1 mole. Now this number, we call it Avogadro's number. Avogadro. Now, Avogadro's number is equal to 1 mole. So Avogadro's number is that many particles, and that means that that's how many particles are in 1 mole.
Is mole in here?
Pardon me?
Does mole have in here?
No. So the unit mole, M-O-L, is short for the German word Molekülergewicht, or something, which is literally translated into molecular weight. So the term mole comes from this word, and it means molecular weight. So where do we get this? We need to remember we're going to actually go back to our ideas from almost the beginning of our unit that we're going to have to include. So we talked about atomic molar mass at the beginning of our unit. So in your periodic table, in our periodic tables, which one was the atomic molar mass? Say if we were looking at carbon. Credit? Yeah, the 12.01. So when we look at atomic molar mass, each element found on periodic table has a atomic molar mass. Did you put that in pencil?
No. Yes.
Okay, well if you did, if you didn't, I want to give a different definition actually. If you put it in pen, just write in the other definition below it, okay?
Can I borrow Josh?
Yeah. Sorry, I realized I had something else I wanted to put. So the definition is the weighted average mass of 1 mole of an element's isotopes. Sorry. So we'd already talked about that when we, but you didn't know what a mole was, kind of when I brought up the last definition. So it's taking 1 mole of an element, and that's its mass. Okay? The units are in grams per mole, because it's the mass per 1 mole, right? So mass per mole. So it's grams. So mass is measured in grams, and moles are just MOL. Okay? Now, the molar mass of any compound then is essentially a similar thing. So it's the mass of 1 mole of any pure substance. So this is also in grams per mole. So let's say the atomic molar mass for carbon, what was that, did we say? 12.01 grams per mole.
What,
Go ahead.
what is that definition in blue? What's that like saying?
Well, I can give you an example, or do you want me to read it?
No, I'm just like, what's it saying?
Oh, I'll give you an example. I'll finish explaining. Yeah. So this mass of 1 mole of a pure substance, we determine it by adding the atomic molar mass of each element. Sorry, you didn't really have enough space there. Adding the atomic molar mass of each element for that compound. So I'll give you an example of what that is, and I think that you'll be able to understand it more. So we add up everything. So, okay, I'll show this to you. This zoomed out too far. I'll go back. So this guy, this is Avogadro. Isn't he handsome?
Whoa,
I just met you, and this is crazy. But here's my number, so call me maybe. It's Avogadro's number.
is that actually what you look like?
Sure. So adding the atomic molar mass of each element for that compound. Okay, so you want to see an example of how to do that? What that even means? Can I go now? Oops, sorry. Okay, I'll go back in a bit.
That's good.
Okay. What do you get when you cut an avocado into 6.02 times 10 to the power of 23 pieces? Guacamole. Right? That's pretty good, eh? Chemistry cat, he knows what's up. Okay. So I'll show you how to do this. So what if it says then, what is the molar mass of nitrogen? So nitrogen as an element. So what is nitrogen as an element? It's a gas, okay. What's its like chemical formula? N2, very good. So there's 2 atoms per every 1 element of nitrogen at room temperature. So we have to go, so we take its atomic mass, which is what, 14.01, right? Grams per mole, that's the unit, so that's the big M, is equal to 14.01 grams per mole. So you need to use a big M, or an uppercase M, to represent molar mass. Okay? So this is the atomic molar mass for this element. Now, then you count how many atoms there are. So now we have to times this by 2. This is why I said bring your calculators. Well, this one's easy. Okay? Yes. So now our answer, we have 28.6 0.02 grams per mole. The next one you will need your calculator for sure.
So that's still like per mole?
Yes, so that's how many grams of nitrogen there are if I had 1 mole of nitrogen.
So you times it by 2 because the nitrogen has 2 moles.
Yes. So now think about this. So this is a challenger thought. How many, okay, so this is per 1 mole of nitrogen. How many particles of nitrogen would be in this 1 mole? There's just 2 particles per 1 mole?
Isn't it that same?
Isn't it that same?
This is how many particles
For one.
per 1 mole.
So you times that by 2?
Nope.
You times that by 20 equals 0.
Nope.
Don't you just leave it the same?
Yep. If this is how many particles I have in 1 mole, how many moles do I have here? I only have 1, right? Because this is how many grams are in 1 mole. So this is 1 mole. If I had 1 mole of nitrogen, that's how many grams I would have. So how many particles in 1 mole? Always, right? Yeah, this is always how many particles are in 1 mole. Kind of crazy, hey? So as a side note, you can put, this is 6.02 times 10 to the power of 23 particles in 1 mole. That's kind of a harder application though. If you don't get that, that's okay, but that's like an advanced connection. Okay, so now let's do a harder one. So Devin, when you were asking, well, what does the molar mass mean of a compound? We're going to do one of those right here. So what is the molar mass of iron 3 hydroxide? So we need to write out the compound. So back when we had to learn how to do all our naming, it's going to apply here. So what does the 3 mean there?
That's charge.
That's the charge, yeah. So I'm using iron 3 plus, and what's hydroxide? OH minus. So now I crisscross to get my compound, and I have Fe bracket OH bracket 3. So now,
Can you see if that actually got soluble?
no, that's not
You don't have to put the
applicable.
states either.
No, that's not really what we're concerned about. If you want to, though, if you want to put the state, we would know at room temperature, it would just be solid. But we are just concerned with the molar mass, so we don't have to, but it wouldn't be incorrect if you chose to. So what we do is we write out all the things that we're using. So we have, how many irons do I have in this compound? 1. How many oxygens in this compound?
3.
3. I have 3 oxygens. How many H's? 3. So you count up how many of each you have.
So you can break them up then?
Yeah, so this isn't a balancing thing. This is like a totally different idea. So we do break them up because we want to break it down into each atom. So now you times them by the molar mass of that element. So now you go to your periodic table and you go to iron, which is number 58, or 26, sorry. So what's the molar mass of iron? Yeah, 55.85 grams per mole. So times that by 1, that's obviously going to stay the same. So 55.85 grams per mole. Then you go to the oxygen. What's the molar mass of oxygen? 16, right? Yeah. Grams per mole. So then 16 times by 3 is what?
48.
Yeah. So we got 38 grams per mole. Then you go to hydrogen, and you see what it is there.
I think it was 48.
Oh, sorry, thanks. Josh was trying to tell me. Thank you. Hydrogen is what? It's really light. 1.01. So then we have 3.03 grams per mole. So that's how much it weighed for the iron, for the oxygen, and for the hydrogen. So now we add them all up together to get the total molar mass of the whole compound. So you take out your calculators and add them all up. $106.88?
Yep.
Okay, that's our final answer. Now, you need to start also reviewing your significant digits because that will come into play during part 2 of this lesson. But for now, just include all of the significant digits that you can. So, I'll give you another workbook. It's definitely not as long. But before that, I'm going to show you a little video on moles.
So if we're using significant digits,
Just use as many as the periodic table gives you for this part. But for the next part, you'll see that you'll need to use your significant digits.